A very good morning and welcome back to my channel, which is Teacher Cool. So here we are with a new lecture, with a new video, with a new topic, and you can say the second last topic of this chapter, which is baryons and mesons. So till now in our previous videos, we have discussed about the strange particles and their origin and their decay modes, their properties, then sorting of those particles, how they were created, what were their interactions. And based upon that, now we have come to a point where we need to know about the next generation of these particles. So basically we will be talking about the baryons and the mesons. Now we talked about muons, pions and then kaons. Kaons को study करने के बाद we were talking about that they are being originated with strong interactions, but they are decaying through weak interactions, so we call it a strange property and hence the name strange particles. So after the kaons were discovered, it was also observed that when kaons are created, short-lived particles with greater mass than proton. I am again repeating, earlier the pions, muons and kaons had very large mass, but it was less than proton. But now it was observed that even short-lived particles having mass greater than the mass of proton were also, or you can say may also be created, and since these particles are created through strong interactions, their name would be hadrons, right? But they decay to protons as well as to pions, right? This is also correct, but we are saying that hadrons they decay to protons, but kaons जो हमने discover किए थे, it was observed that kaons would never ever decay to protons. Again a discrepancy, we are saying that hadrons are decaying to protons, or you can say protons are included in their decay products, but kaons के decay products में there are never protons. So we say that based on these two observations, hadrons must be of two types. What will the two types? First will be the baryons and the second would be the mesons. So when we are talking about hadrons which are decaying to protons, the first thing which comes is the baryons. So we say are the baryons are protons or any other particle antiparticles which are included in the hadrons which decay to protons directly or indirectly, like maybe in a chain reaction or in a indirect way, they have protons in their decay products. So those particles will be known as the baryons. For example, protons, neutrons, neutron getting converted to protons. Then the second part is mesons. Now we say that mesons are those hadrons that do not have protons in their decay products either directly or indirectly. So the examples would be kaons and pions. Now baryons and mesons, we now know what are baryons and what are mesons. So basically these are two types of hadrons, and hadrons and leptons are basically two types of matter and antimatter. So in a way we have a you can say there is a family chart. These are the grandparents, matter and antimatter. Then we have hadrons and leptons, and in hadrons we have the baryons and the mesons. These are the grandchildren, and for example proton, neutron, kaons and pions. Now when we are saying that baryons and mesons are two types of hadrons, we also say that baryons and mesons are further made up of quarks and antiquarks, which will be our last topic of this chapter, and we'll come to it in details. For till now, it is just remember that baryons and mesons are further made up of quarks and antiquarks. Related to leptons, we are coming to leptons only. So this part I'll come back again, but for this abhi it is clear. Now let's come to the leptons. When I'm saying leptons at work, that means leptons ko we are using as colliding particles or as targets, and their results and their observations and the trajectories will be observed and studied. So we say leptons collisions. So basically leptons kaun se honge? Leptons are the particles which are, I am saying, neutrinos, muons and electrons, right? Leptons, we already said that those particles which never show strong interactions, and here we have neutrinos, antineutrinos, muons, antimuons, electrons, positrons. Three particles and their three corresponding antiparticles. But what if the entire world would have been made of these leptons only? There were no hadrons or baryons or mesons. So what will happen? Then we'll say that neutrinos, they hardly interact, as I've again told repeated times, and here also I'm going to tell you that billions and billions of these neutrinos are passing through Earth per second. Yet we do not detect them because they do not wish to interact. They are very non-interactive. So there will be no reaction. Then the second particle is muons, and muons are so short-lived that they could hardly do anything. And electrons are those fighting brothers which do not do any work. They just keep repelling each other. So in a way, if my world have been made up of only leptons, I'll say my world would be very boring. There will be no reaction. But we say when lepton reacts with lepton, they can make hadrons. Like electron, when it reacts with positron, we have two jets of hadrons. So we can say this was the annihilation process, electron colliding with positron, particle with antiparticle, two gamma photons would have been created. So I'll say either two neutrinos are being produced, which are particle antiparticle, and every particle is made up of quarks and antiquarks. So we can say two particles which are, one is particle quark, one is antiparticle which is antiquark, are produced, and to conserve the momentum also they flew off in the opposite direction. So let's come to neutrinos. So what are the basic properties of neutrinos? So neutrinos travel with the speed of light, right? We know this. Billions of neutrinos pass through Earth unreactive. We know this. They are hardly produced in accelerators. Yes, neutrinos are so non-interacting that even in the cloud chambers or accelerators, they are hardly produced. There is a very less count. And neutrinos and antineutrinos, we have two particles, but when I am talking about this thing and when I am talking about muon plus antimuon giving out neutrinos, I'll say this neutrino and this neutrino will be different. They will have some difference in them, because agar wo same hote, then equal number of electrons and muons would have been present, which is not true, and hence we say these neutrinos show different properties or different characters. So we say that neutrinos, antineutrinos produced in muon decay are different than proton, neutron, or we can say it is never is same as the neutrinos and antineutrinos produced in electron decay. Yeah, beta decay you can call it. So in both cases they will have different characters, and this also we know that if they were same, then same number of electrons and muons would have been present, which is not true, and we know this fact, and hence we conclude that these two are different. Now from here we'll go to lepton numbers. Now when we are talking about interactions, like here I have written electron, it is colliding with the positron and two jets of leptons or hadrons are being emitted out. So in those cases, just like in kinematics or in dynamics, we follow certain conservation rules, which are conservation of charge, conservation of mass, conservation of energy, conservation of momentum. So same way here we will have the conservation of lepton number. L, capital L will be its symbol. So we will have a particular lepton number for my leptons. Like for electron, all the particles will have +1 lepton number, like electron, electron related neutrino, muon, muon related neutrino, tau, tau related neutrino. These all will have lepton number +1, whereas their antiparticles, which is positron plus, not plus, positron, then antineutrino of electron, muon, antimuon, then antimuon ka neutrino, then anti-tau and antineutrino. So these antiparticles will have the lepton number of -1. So in the next video we will bring the interactions and the reactions where we will show how to conserve this lepton numbers, and sometimes we need to conserve this lepton numbers separately also. We will face a few equations where we will have muon related neutrino and electron related neutrino, and we will have to conserve the lepton numbers separately, because if we conserve it directly our equation is verified, but that equation is not allowed because separately they are not conserved. So there are a few discrepancies, and very interesting topic, very mathematical, very easy, which will bring in our next video very soon. So till then, stay connected. Do leave your doubts in the comment section. I'll revert it back for sure. And do not forget to like, share, subscribe to my channel, which is Teacher Cool. Till then, thank you so much.